All right, so we wanted to introduce this powerful tool that we have now that we understand derivatives. All right, before we do that, we're going to do a quick review of limits because it'll come up in our next video. All right, so see if you can recall what the following notation means. So take a second and see if you can remember what this means. And the answer is as x gets close to a, my function, which in this case is f of x, gets close to some number. Right. So if we had like the limit as x approaches 2 of x equals 3, that means as my x values are getting closer and closer to 2, my y values are getting closer and closer to 3. All right, so my function could look something like this. Because as my x values get close to 2, my y values get close to 3. All right, so that's what the limit notation means. All right, and then we learned previously how to solve for limit. We had a question like this. All right, the first thing you always want to try to do with the limit is plug in the number. If I plug in -1 here, -1 plus 2 is 1 over -1 plus 1. That gives me 0 over 0. All right, so this doesn't tell me what the limit is because 0 over 0 could be a bunch of different things. So we did figure out some way to evaluate this limit. And the way we learned this was using the conjugate, which is the same thing except for with a plus sign between these terms. And that's going to give me the limit. All right, we multiply by the conjugate because that gives me the difference of squares. On the bottom, I don't want to combine stuff. And that top x plus 2 minus 1 is going to simplify to x plus 1, so those are going to end up canceling out. Right. And now that I cancel that thing out, now I can again try to plug in -1, and when I do, I'm going to get 1 over the square root of 1 plus 1, which is 1/2. So my final answer is 1/2. All right, so this is something that we learned in a previous unit using this conjugate to help us simplify our fraction, so then we can plug in the limit that we care about. All right, sometimes you run into an issue because there's really no algebra you can do, especially once you start using trig and logarithms and exponentials and all that stuff. All right, the algebra tricks aren't there anymore. All right, so we have to figure out other ways we can do limits. All right, another way that we've learned how to do limits was using graphs. All right, so I were to graph this function. All right, it's my limit as x approaches 0. So I'm looking in this area here, right around 0. And when I'm in that area, all my y values are in that area, so this should be equal to 1. All right, because as my x values get close to 0, my y values get close to 1. All right, so that's another way we can figure out limits. We're just kind of remembering what this notation means and some ways that we learned before. But now we won't have to do all these tricks anymore because we're going to learn another way to evaluate limits.